I'm Beth Wilson. I'm one of the hosts of 730, a television program for middle school students produced at the National Air and Space Museum. Today on What's New in Aerospace, we're going to be talking about the summer solstice. And we'll be taking your questions. So put them in the comment section. We'll get to as many of them as we can. And also let us know where you're watching from, or if you're watching with a group, and we'll give you a shout out. Joining me today is astronomy educator Shauna Edson.
Hello.
Shauna, thanks for joining us. We are talking about the summer solstice, so I'm going to start with the most obvious question. Shauna, what is a solstice and how often does it happen?
Yeah, that's a great question. So solstice comes from the Latin word for sun and still. So it is the day the sun stands still. What that really means is it is the day that the sun gets as high or as low as it's going to get at midday. So for us in the Northern Hemisphere, it is the longest day of the year, and it is the first day of astronomical summer. For our friends in the Southern Hemisphere, it is the first day of winter, or the first day of astronomical winter, and the shortest day of the year. And it happens because of what is on this diagram. It happens because the Earth is tilted. So we are spinning, we are a ball, we're spinning, and we're going around the sun, but we don't spin straight up and down. We are tilted about 23.5 degrees. So on this diagram, as you can watch, you see the Earth going around the sun, and there's a little line through it that shows where the north and south poles are that is tilted. So in the northern half of the Earth, over on the left side of the image where it says summer solstice, so northern half of the Earth, the tilt is toward the sun. So that does a couple of different things. It means that the sun gets higher overhead for most of us. It means that we're getting more direct light from the sun. When the sun's at a lower angle, the light's more spread out. We don't get as much concentration of light and heat energy. Similar to how in the morning when the sun's low, it's not quite as warm, and then at the midday, it's warmer, and then it starts to cool off when the sun gets lower toward the end of the day. Similar things happening over the course of a year. So when we're tilted toward the sun, we get warmer weather, longer days, and the day that we are the most tilted directly toward the sun is the summer or June solstice. So it's summer for us, but the June solstice is the winter solstice for our friends in the Southern Hemisphere. And solstices happen twice. There's two of them on this diagram. There's the summer one when the northern half is tilted toward the sun. And on the other half of our orbit, there is the winter solstice for us, summer solstice for the Southern Hemisphere, when the southern half of the Earth is tilted toward the sun and the northern half is tilted away. So all consequences of living on a tilted planet.
Now, you mentioned the June solstice. When is that this year?
So this year, the June solstice is this Sunday, June 20th. It can change a little bit. It's usually around June 21st. It can shift a day or so depending on whether we've had a leap year recently.
And on that diagram, it didn't just note the solstice, it also noted the equinox. So can you tell us what is the equinox and how is it different from the solstice?
Yeah, so in our orbit around the sun, there are essentially these 4 points. There's the solstices, the 2 times when we are tilted the most toward or the most away from the sun. Equinox is in between that, and it's when we're tilted neither toward nor away from the sun. So it's when things are kind of even. So on the left side, the summer solstice is when the northern half of the June solstice, northern hemisphere tilted toward the sun. As we go around the sun, there comes a point where the sun is to the side of our tilt. So that would be autumn, autumn for northern hemisphere, spring for southern hemisphere, where the sun is shining evenly on both hemispheres. So our day and night are about equal in length, and our weather is fairly mild in the spring and fall because we're getting a moderate amount of solar energy, not super long days and not super direct light. So the summer solstice happens when you're tilted toward the sun, and then you do quarter orbit, and then it's even amounts of light, so equinox, spring or fall. And then you go around another quarter of an orbit, and then the northern half is tilted away, so it's winter. Southern half is tilted toward, so it's summer. And then you keep going another quarter orbit, and there's another equinox where, again, the tilt is to the side from the sun. So it's an equal amount of day and night and a moderate amount of solar energy.
We've got a lot of people watching. We've got groups in Illinois, South Carolina, Florida, Ukraine, and Mexico.
Oh, wow.
Please keep those questions coming. If you have questions, put them in the comment section. We'll get to as many of them as humanly possible. Can you tell us a little bit? Someone would like to know, how do the solstices affect the weather on Earth?
So the exact day doesn't specifically, but you're absolutely right that the fact that we are tilted, that we have solstices and equinoxes, and parts of the earth get different amounts of sunlight over the course of the year is exactly why we have seasons, and it does cause changes in our weather. So during the summer, when we are tilted toward the sun, and this map shows beautifully, this is showing the amount of reflected solar radiation. So where it's darker, there is less reflected light, and where it's lighter, there's more. The upper half is in December. So if you look at the northern part of the map, the top of the map, it's totally dark. That's up near the pole. It's tilted away from the sun so that the sun actually doesn't rise at all for almost 2 months. So up north, it's much colder. You're tilted away from the sun. Parts of it near the pole can't see the sun at all for a while. But in the southern half of it, they're tilted toward the sun. So there's a lot more direct sunlight and it's a lot hotter for them. Now, in that lower half, it's the opposite. The northern part is tilted toward the sun, and that southern part, which is darker, is tilted away. So this is showing just this drastic difference in how much sunlight the parts of the earth are getting at the two solstices. And that translates both the more direct light in the summer when we're tilted toward the sun and the longer days that result from being tilted toward the sun. You may notice in the winter, at least for us, we have maybe 9 hours of daylight, whereas in the summer we can have up to 15. So when there's more time for the sunlight and energy to heat up our atmosphere, it will change the weather we get. The temperature at the surface will be warmer, but in a lot of cases it will get more humidity. We might get more, I've started noticing more thunderstorms nearby because storms like that need heat to form. So our weather isn't necessarily different on the day of the solstice, but the period of time at and just after the solstice when we've been getting the most solar energy, it's heated up our atmosphere a bit more and it's allowed for storms to form and for different patterns. In the winter, oftentimes it's colder, the air is more dry, at least in the mid latitudes where I live. And so, yeah, you'll notice those temperature and weather differences as well.
Okay, we've got people watching from Texas, Virginia, Nigeria. Keep those questions coming. Someone would like to know if the solstice affects the migration of animals.
Oh, that is an awesome question. I don't know for sure if animals detect the fact that the sun has gotten higher in the sky up to the solstice day and then starts going down again. But animals are very aware of seasonal patterns of length of day. And so I'm not a life scientist, but I know people who study life science. And I know that a lot of animals, especially ones that migrate, take their cues from the weather, the temperature, and possibly the length of day as well. So I'm sure there's a relationship there. I don't know exactly what it is, but that's a really great connection that living on a planet with seasonal changes affects the creatures that live on it.
I do vaguely remember that hummingbirds will all at once start to disappear from an area, and it has to do with the sunlight. I believe that's correct. I'm very into birds. I vaguely remember reading that, and I'm waiting for the hummingbirds to show up at my feeder these days. Someone would like to know what would the Earth be like if it wasn't tilted, and what other planets have a similar tilt?
Oh, those are two really great related questions. So I have a diagram that's from Time and Date that I really love that shows the tilt of the Earth and the sun shining on it. So because we are tilted, we get this change in how much light is in these different places and we get these seasons. If the Earth was not tilted, even so, you can see that up at the poles, the sunlight, even when we're the most tilted like when the North Pole is the most tilted toward the sun angle is still really low. And down near the equator, even when we're tilted toward or away, or even at equinox, when you live near the equator, the sun's always kind of mostly overhead. So different parts of the Earth experience sun and heat and temperatures a little differently just because of where we are on the globe. So around the poles, even if the Earth was straight up and down and not tilted, it would be much cooler at the poles because the sun would be at a low angle all year. And at the equator and in the tropical areas, it would always be warm because the sun would always be fairly overhead. So we wouldn't see the seasonal change over the course of a year, but the different parts of the Earth would still experience different types of temperatures. And the question about other planets is really great. I have a diagram of the tilts of a bunch of different planets in our solar system. So there's basically kind of three groups of solstice types in the solar system. So there's the Earth-like planets that have a moderate tilt, like 20 to 30 degrees. So Earth, Mars, Saturn, and Neptune all have this sort of moderate tilt with respect to the sun. So as they go around in their orbits, they have solstices and equinoxes. And so their northern or southern halves will experience a summer, a warmer period, and a winter or a cooler period. Those will take different amounts of time. Mars's orbit takes about 2 Earth years, so its seasons are twice as long as ours, but it does have seasonal changes. So those are the Earth-like planets that are sort of moderate tilt. Then you've got the extremes. So we have Uranus and Pluto. Pluto, this diagram is from 1999, so it's before we changed the definition of a planet. I love Pluto. I don't care what we call it. It's awesome. And Uranus and Pluto both are really tilted. They're basically on their sides. So they have extreme seasons and extreme solstices. So for Uranus, there's a point when its North Pole is essentially looking right at the sun. So the north half of it is seeing the sun all the time, and the southern half of it doesn't see the sun at all. And its year is 84 Earth years. So for 20 years, you're just in the sun all the time. And then you have an equinox and a day and night, and then you're in the dark for 20 years. So Uranus and Pluto both have these extreme seasons. And then for Mercury, Venus, Jupiter, and Ceres is the other dwarf planet where we know its tilt's about 4 degrees. For those four, they're almost straight up and down. So the sun really doesn't change. They have no seasonal variation to speak of. So there's a variety of amounts of solstice in our solar system, but any planet with a tilt can have a solstice.
We have people watching in Texas, Virginia, California, Nigeria. Keep those questions coming. You did answer one of the questions, which was, does the solstice happen on other planets?
Yes.
Does it affect weather on other planets or storms on other planets the way it does us here?
Yes, absolutely. So I know we have a picture of Saturn, because Saturn has a tilt kind of like Earth. It was about 27 degrees or so. So it experiences a summer and a winter. Its orbit is about, I wrote it down. Saturn's orbit is about, looking at my notes, it's about 30 years. So its seasons are longer than ours, but when the northern half is at solstice, when it's tilted toward the sun and warmer, we do see changes. So in this picture, that bright sort of blurble across the top of it is a storm that was seen by the Cassini spacecraft that was orbiting Saturn for a very long time. And over the course of time that that spacecraft was orbiting, we saw seasonal changes on Saturn. We saw storms appear. I don't remember if it was right at solstice or after it, but there was definitely a temperature change and storms that we saw form as the solstice was happening, as it was changing where it was relative to the sun. And I know on Mars, we've seen in the winter on Mars, it gets cold enough that some of the carbon dioxide in the atmosphere actually like solidifies out and becomes snow on the ice caps at the poles. And then in the summer, we've noticed these dark lines that appear on crater walls and kind of move. We're not sure whether that is water underground that's melting. Now there are some scientists saying it's actually sand. It's a darker kind of sand that's flowing, but it happens as it goes into Martian summer. So it must have something to do with the temperature, things thawing and releasing stuff that was frozen. So there are things that will change like that on these planets. Yeah.
So studying seasonal changes on other planets tells us a lot, doesn't it?
Mm-hmm. It does. Yeah.
We've got people watching from North Carolina and the United Kingdom. If you're watching this and you're enjoying it, please share. And for those of you who are watching, I want to remind you to put your questions in the comment section, and we'll get to as many of them as we can today. Our next question is, what are the different ways scientists track the path of the sun?
Oh, that is such a good question. So humans have looked at the sky, noticed the movements of the sun and moon and stars for as long as we've been on this planet. The sky has been there and we've noticed it. Early on, before telescopes, you could still absolutely see where things go in the sky. And this is actually something you can do at home. You can notice where the sun is when it rises. And if there's a landmark near where you live, maybe there's a house or a tree or something that's like, okay, that's where the sun is when it rises. You could notice where the sun is when it sets. And you kind of remember those landmarks. And then as the year goes on, where the sun rises is going to shift a little bit as our tilt changes. When we go toward one solstice to the other, the sun is going to shift what landmark it rises or sets close to. So noticing those changes just based on landmarks on Earth is one of the first places that you would see that. There are tools that will allow you to measure the angle of the sun in the sky. So we've tracked the path of it, how high it gets, how long it takes. This is a diagram. The figure 8 shape is what's called the analemma. And that is the pattern that the sun traces in the sky if you capture its position in the sky at the exact same time every day. So it doesn't just go up and down. It actually kind of moves back and forth a little bit. That the fact that it goes up and down is because the Earth is tilted. The figure 8 shape is because our orbit is not quite a perfect circle. It's kind of a squished circle we call an ellipse. So where the sun appears in the sky kind of side to side shifts a little bit over the course of our year because of that orbital offset thing. And so that pattern had been noticed. People would, just at the same time every day, note where the sun is and realize there was this pattern. So from the Earth, there have been a lot of, as we've gotten more tools, there have been newer ways to track its position exactly. But the basic way of doing it is to observe it, use a landmark, and notice where it is. Now, don't look directly at the sun. Your brain and eyes will tell you that's too bright. Listen to your brain. But you can notice where it is and what it's close to. So tracking how it changes at the same time and its height in the sky over the course of a year, we have a really beautiful video that it compresses a whole year into a few seconds. But it shows the effect for us on Earth. I've talked about the tilt and stuff. This is Traces of the Sun by a photographer in Hungary. And he took photos of the sun every day. So this is the course of a day from morning till evening. And this was the June solstice in 2015. So here's the path the sun took through the sky. And now this is every day going forward. So now we're in August and then September and October. And you notice the sun, it's still tracing this path, but it's getting lower. So that was the winter solstice, December solstice. Now it's going up higher in the sky again as we get into March and April and May and back to June. The dark spots are just places where it was cloudy, so he couldn't see the sun. But that is how much it changed in the sky from the June solstice for us, summer solstice wherever you are, all the way, like the highest it got in the sky was really low in December. So that's like 1 year's worth of change on Earth with our moderate tilt. But photography like that is a great way to track the sun. And that's been one of the main ways that scientists do that. Yeah.
I want to just point out, I apologize. It is a very nice day here. I thought they were done mowing the lawn, but apparently they're not.
I didn't
S
hear anything until you said something.
Yeah, well, it's so I've I closed the set of windows that I thought they were going to be working on, and that side they were, but that wasn't the case.
Yeah, it's all good.
Alika, who is 7, wants to know, does the solstice make the bats come out later because it gets darker later?
Oh, that's a really good question. So, yeah, the solstice affects how high the sun gets in the sky and how long our day is, which will change when the sun rises and sets. And animals have a sense of time. Most of them don't use clocks the way we do with numbers for the hours. So they take their cue from how dark or light it is. So around the solstice, when the sun is up much later, it will, for any nocturnal animals that wait until it's dark, bats, owls, lots of animals, it will change what time they come out because they're following when the sun is up. That is a really great observation.
I think that if you have pets, particularly when we change time from like regular time to daylight savings time and back, they they don't know what time it is. They're following the sun. I mean,
Right.
when we spring forward, my cats don't care. It's
Right.
time to eat when it's time to eat.
Mine too. They want dinner when the sun and their tummy clock says dinner, and they don't care that it's now an hour later. They are actually quite unhappy that it's an hour later. Yeah.
Yeah. And I
Exactly.
think if you just observe the pets you have at home and you can see how light affects them. And even I have trouble in the summer sleeping in really late because the sun comes up.
Yes.
Um,
And
we've
we live in this mid-latitude where we always have day and night, but in the parts of the earth near the poles where even like when it's tilted toward the sun, even the night side, the side of the earth that's away from the sun is tilted enough that at midnight they can see the sun. The state of Alaska is known as the land of the midnight sun, and other northern places, parts of Russia and Norway and Sweden, they can see the sun at midnight because of that tilt. And so you have to get a mask to be able to have darkness so you can sleep. It really can mess with your cycle. And in the same way, in winter, when they're completely tilted away, they don't see the sun at all for several weeks. And so you have to have a lot of good lamps to help your brain wake up. Like, no, it's daytime. So
yeah,
yeah, our
the
friends at the
sun.
poles have some extremes for that.
Yeah, the sun really does affect us. We have got people watching in North Carolina, in Dulles, Chicago, the United Kingdom, and Austria. One of the questions that has come in is what places, and you did answer this. There may be more though. What places in the world do not see seasonal change? So you talked about the
Yeah.
extreme, where you got the land of the midnight sun and it's sunny all summer, but where do you not see a lot of change?
So the extremes are at the poles of the Earth. And so the equator, that area, the area within 23.5 degrees of the equator is known as the tropics. And so that's a place where the sun can be overhead and is always somewhat close to overhead. The lowest it gets is 23 degrees off of straight overhead. So in the tropics, we think of that as being warm. Tropical weather is warm, humid weather for us. So around the equator in those tropical regions, they have seasonal changes, but it's never really winter in the way it is for those of us that are closer to the poles. There tends to be a wet season and a dry season because the changing angle of the sun will change how storms form. But yeah, these pictures from space, the Earth is straight up and down in all of these photos. The angle that you see changing is where the sun is shining on it from. So you notice right in the middle of the Earth, the equator is a belt around the middle of the Earth. When we're tilted toward it, the sun's shining on it. We're tilted away, the sun's shining on it. And at the equinoxes, where the shadow is straight up and down, the sun's just shining almost overhead on the equatorial and tropic regions of the Earth all the time. So it's a great place to vacation if you want warm weather most of the time. So they do have there are changes in the wet and dry cycles, and there can be a monsoon season depending on how much land and ocean you have there. The ocean hangs on to heat. in a really strong way, so you can get some changes in weather, but it's going to be warm most of the year because the sun's never far from overhead. Yeah.
We have people watching in India as well today. And Shauna, let's ask the audience if any of them have some interesting solstice experiences depending on where they live. I know there's a question here, and this sort of addresses that. Someone would like to know if the sun and its tilts affect temperatures in Antarctica and Australia, and you said it does, but in very different ways. I mean, in Australia now, it's wintertime.
Mm-hmm. Yeah, Sunday's going to be their first day of winter, and they are. Australia is closer to they're sort of mid-latitude, like the United States is. I mean, it's a big country, so parts of it are much closer to the tropics than others. But yeah, and even Australia and Antarctica. Australia is covered with land, so there's rock and vegetation, which absorbs a fair amount of sunlight. Antarctica is covered in ice, and ice is bright white and reflects a lot of sunlight. So it matters what surface the sun is hitting, how much of the sun's light and heat it's going to absorb versus reflecting. And then, of course, there's the fact that in Antarctica, like around the North Pole, they get midnight sun during the summer, and they get almost 2 months of true dark night continuously when it's winter for them. So it's, each of the poles will experience extremes. Yeah, this is great. So there's, the North Pole tilted toward it, the South Pole tilted away, and you can see that part of Antarctica, even on the side that's technically toward the sun, it's tilted away and it doesn't see the sun. And the Earth, the northern part of Earth has a lot more land, and the southern part has a lot more ocean. Ocean and land will absorb and reflect the sun's heat in different ways. So the variation of the seasons is actually a little different from the northern hemisphere and southern hemisphere. Northern hemisphere experiences slightly more variation in temperature and weather from our winter to our summer because land changes temperature a lot with the sun. Water, the ocean, it takes a lot of energy to change the temperature of water. So the ocean from winter to summer only changes about 10 degrees Fahrenheit. It's really not a big change because it takes a lot to change the water's temperature. So with the huge amount of ocean in the southern hemisphere kind of maintaining a constant temperature, there are parts of land that will heat up and cool down, but the ocean sort of regulates that amount of temperature change. So the seasons are a little less extreme for our friends in the southern hemisphere.
And you brought this up earlier, and it's come up in one of the questions. Is there a better term than the longest and shortest days of the year?
It's a good question because the Earth is spinning at the same rate. It is 23 hours and 56 minutes for us to do a full rotation every day. And so we talk about it as the longest and shortest days of the year because of just the amount of time from sunrise to sunset. So it's the longest amount of daylight on the summer solstice where you live, and the shortest amount of daylight at your winter solstice. But the day is still basically 24 hours, and that doesn't change. So it isn't a strange term. I don't know that I've heard another way of describing it, but I would challenge all of you to kind of think about what it means and find an explanation that you like better if longest day feels confusing.
And shortest day.
Yeah,
although once the shortest day is done, I'm like, oh, good, it's going to get lighter because I miss the sun in the winter.
Well, right, because right now we're probably noticing that the sun is up really late and we have these nice long days. And I love the summer solstice; it's the longest day, and then there's that reminder of and now we're going to start losing a few seconds of daylight each day. I don't really notice it until like July or so. Around this time, it's not around the solstices. The amount of daylight isn't changing very much, so we're not losing very much. Around the equinoxes, when our tilt is shifting from toward through sideways and into away, around the equinoxes, our daylight is changing by 3 to 4 minutes a day. It's really, it's a lot per day in that
Why does it get so
middle,
much faster at that time?
because because of the way that the tilt works, and that the difference is, I'm not explaining this well. It's why the word solstice is the sun stands still. In that little figure eight analemma, it goes slowly over the top part. Yeah, around the curves at the edges, it goes really slowly, and then it moves pretty quickly through that long stretch, and then goes slowly at the other curve. So it has to do with just the way that the curvature of the Earth hit and the sun hits it, and the way that the shift is. It's not an equal amount of change around the whole year.
Shona, I always learn something when I'm on these live chats with you, which is
I hope
great.
that part made some sense. That felt like a wall of words.
It did. It was helpful for me.
Oh,
Does the solstice influence the speed of the Earth's going around the sun?
Oh, so the tilt of the solstice doesn't. But another thing about the Earth's orbit does. So, like I've said, that the Earth's orbit is not a perfect circle, it's kind of a squashed ellipse. One of the things about planet orbits that Johannes Kepler figured out centuries ago is that when you have something like a sun or a star and you have a planet orbiting it, if the orbit is an ellipse, so that sometimes you're closer to the star and sometimes you're farther away, when the planet is closer to the star, it's moving faster, like physically faster through space. And when it's farther away, it moves slower. That is a gravity thing. When you're closer to the object pulling on you, you have to move faster to maintain your orbit. And when you're farther away, you go slower. So Mercury, closer to the sun, orbits faster than the Earth, which orbits faster than Jupiter. So in our elliptical orbit, when we are closest to the sun, we are moving through space a little bit faster than when we're farther away. And a lot of people, this can be confusing, because a lot of people think that the seasons are caused by us being closer and farther away from the sun. But we were talking about, it's the tilt, it's the angle of the sun, the directness of the light, and the number of daylight hours heating up or not heating up our atmosphere that cause the seasons and the weather changes we know of. But what's amazing is that our orbit, the closest part of our orbit, it's not a very big change. It's very, very slight. But the time when we are closest to the sun, the whole Earth closest to the sun, is in January. And when we're farthest away is in July. So it lines up with the Southern Hemisphere seasons pretty well, but the difference in our distance is so little that it doesn't make a measurable difference in our temperatures. However, it does affect the speed that we're going around the sun. So we are moving a little bit faster in January than we are in July.
I just want to mention, and you probably have, you can probably comment on this a little bit, that watching the sun and the seasons and the stars culturally has been very important to people for building calendars and keeping time. Do you have one of your favorite timekeepers that you can think of that?
Well, so archaeoastronomy is the study of structures or things humans have built that relate to the sky. So a lot of people know about Stonehenge in the United Kingdom, which is aligned. It's a circle of stones where they are aligned to the sunrise on the summer solstice and the sunset on the winter solstice. There are a lot of there's a lot of structures like that that are aligned to those positions where somebody noticed where the sun was rising every day and realized when it got the farthest in one direction, which would be on a solstice, and then when it started going back. So there are structures in the Atacama Desert that are where the edges are aligned to the summer and winter solstice sunrises. There's a beautiful structure in India, Jaipur, and there are several of them, but they have these structures that date back hundreds of years that are aligned to the solstice and to the sun's rise and set positions. And it's all of these amazing structures that are meant to observe things in the sky. And those are centuries old. So humans have noticed the positions of things in the sky and how they change, and have built buildings and observing structures aligned with them to help us see them and find them for thousands and thousands of years. It's really quite incredible. There's I know UNESCO has a World Heritage Site that has collected a lot of these archaeoastronomy locations where you can explore them. There's a map where you can see where a bunch of them are, and you can learn more about when they were built and what they show, and things like
And
that.
some of them we don't know how they were built. I mean, it was that important.
Yes.
It's always been that important for people to be able to know
Yes.
what season you're in, what time year is it? Is it Chichen Itza that has the snake on the pyramid?
I believe so. Yeah.
Yeah.
And time, if you think about it, time is incredibly closely tied to astronomy. Our day is one Earth rotation. Our year is one Earth orbit. 1 month sounds like moon. A month is about the amount of time it takes the moon to do one orbit and go through all of its phases. And the days of the week are named, so Sunday for the sun, Monday for the moon. And then in English, it doesn't make as much sense, but the days of the week, the other 5 days of the week are for the 5 visible planets. So lunes is Monday, martes, Mars, Tuesday, miércoles, Mercury, Wednesday, jueves, Thursday, Jupiter, viernes, Friday, Venus, and then Saturday is Saturn, and Sunday is the sun. So all of our markers of time really are based on astronomical observations. Those are the changes that humans have seen, and that is how we measure our time.
That's amazing. And I think you've just blown all of our minds. And with that, I'm going to say that we are sadly out of time. But Shauna, I will be out enjoying this solstice on Sunday.
Yes. Notice your sunrise and sunset. Notice where it is in the middle of the day. And we have the Smithsonian Aerospace. We are celebrating the solstice all this weekend with a bunch of activities and cool things you can do. So go out and look up, just not directly at the sun.
And maybe we can get that link for this weekend's activities into the chat. So we are out of time today. Thank you so much. This has been a great conversation. If you liked today's show or missed any parts, you can head over to the STEM in 30 Facebook page or the National Air and Space Museum's YouTube channel to catch the archive. Those videos, give those videos a like and share them with other people so that more and more people can learn about these fabulous programs. As a reminder, the Stephen F. Udvar-Hazy Center in Chantilly, Virginia is reopened, and we encourage you to come and visit. You will need time tickets. You can find out about those on our website. June 23rd, we have an evening conversation with the author of The Martian, Andy Weir. He will be talking about his new book, Project Hail Mary, and a group of teachers will have a discussion with him about writing science fiction. If you enjoyed this program, be sure to follow STEM in 30 on Facebook and Twitter. If you have any suggestions or feedback, we'd love to hear them. You can throw us an email at stemin30@si.edu. And again, I want to thank you all for watching today, and have a terrific solstice.